The next theme has a complicated explanation, so I would like you all to listen while using your instincts. This is a dot pattern of an eye. It is an analytical pattern of the eye created systematically. It is a creation from 1969. A single dot first splits to 4 dots of 2 by 2 and then splits to 16 dots of 4 by 4. Further splits to 64 dots of 8 by 8 and then splits to 256 dots of 16 by 16. A single dot was divided into finer dots and the image of an eye emerged from the dot cloud. The inversion of 256 is 2 to the power of 8. To this image of an eye that has 2 to the power of 8, 256 dots, now let us merge 4 square dots at a time. It becomes 64, 2 to the power of 6. Further it goes from 16, 2 to the power of 4 to 4, 2 squared. And it returns back to a single point. If we look at this transformation from a dot to an eye arranged in a row, it looks like this. Shall we look at the transformation of the dot again? The single dot is 2 to the power of 0. 4 dots is 2 squared. 16 dots is 2 to the power of 4. 64 dots is 2 to the power of 6. 256 dot is 2 to the power of 8. At this stage, the details suddenly become clear and the eye is sharply visible. In fact, this eye is an eye created according to a matrix that has a numerical structure in every corner. The entire 256 dots part is built by an arrangement of all the numbers from 1 to 8. These numbers are translated into dots of sizes varying in 8 levels to thus create the image of an eye. Vertical 16, horizontal 16. If you divide the whole 256-point grid into 4 compartments, the total number in each compartment is 256. If you add up the number of sections on the top right, you get 256. Bottom right is also 256. All 4 compartments are aligned with the number 256. If you replace it with dots, it becomes this sort of thing. (256) is 2 to the power of 8. In other words, a group of points that are 2 to the power of 8 are aggregated by changing the size from 1 to 8 to form an image of one eye. 8 are 2 to the power of 8 number of dots. Also size difference of the dots from 1 to 8. In this way, it was a single eye supported by an information science structure related to 8. Needless to say, 2 is assigned as 1 bit in information science. This eye, which has a numerical distribution from 1 to 8, has an operation different than before. Now prepare 4 points with various sizes and replace this numerical distribution with new points. First of all, the part of the number 8 in the I array is made a point of size 2 and the number below 7 is made a point of size 1. That results in this sort of a dot group. In the second one, 8 is assigned size 3, 7 is assigned size 2, and 6, 1 is assigned size 1. In the third arrangement, 8 is given size 4, 7 is given size 3, 6 is given size 2, and 5, 1 is given size 1. If we keep this up from the 4th to the 8th, the I is created. By replacing the densities step by step with 4 size points, a new I with 8 density changes was born. If you arrange it one beside another, you will get a new I at the 8th transformation. This is provisionally called the dot I. These dots that change in density in 8 steps are applied to the numbers from 1 to 8 lined up in the 16 by 16 squares of 256 array shown earlier. Then, a great gathering of dot i's with 8 density changes give rise to a large I composed of 16 vertical and 16 horizontal, and I with a double eyelid. I name it eyes within an eye. It is a big eye that has a multi-layered mechanism. While repeating this eye image composition system, we took up the challenge of a project to create one eye with 30 eyes, an eye within an eye within an eye. The 80s was still an era of hand drawing everything. But since we were in the middle of a busy period, we had to give it up. No doubt, the image of a 30-eyed eye is possible. The challenge was to create more complex diagrams out of a diagram that an orderly structure by controlling the numerical values of that structure. Changing the perspective a little, the density variation of this eye that had an ordered numerical structure with 8 level variations is replaced with a variation system using kanji strokes. The eye that has appeared here is created not using density variations but by using 8 kanjis related to seeing like heart, wish, see, soul, etc., which have different number of strokes. Of course, variations using punctuation marks and symbols are also prepared. I also tried making a portrait of a young lady using a combination of kanji and text. The part in the shadow has 7 levels of kanjis, all related to seeing. The bright portion is filled with a vague essay that Mr. Shigo Matsuoka wrote related to seeing. It was a trial presented first in a magazine called Asahi General, after which it was reassembled with phototype setting. Furthermore, using the same technique, I made a digital portrait of Michel Foucault and used it in the design of the magazine Paideia. I made it myself using the electrically powered typewriter. It's a work from 1972. This is the digital portrait included in the main body of the book. I think it was 1971. I was requested by the Ministry of Posts and Telecommunications of West Germany to create a design of the Olympic stamp. At that time, I proposed the idea of this stamp design using characters. The Ministry of Posts and Telecommunication of West Germany was surprised by this pattern and asked me to change it to a dot pattern. The Olympic stamp was finally designed with 4 varieties of dot patterns that you can see here. The design of the commemorative stamps of Sapporo Olympics in 1972 was done not with characters or numbers but using dot pattern. After that, this theme developed into the Image of Image series. This title corresponds to the idea of the eye inside an eye and is a digitized iconographic image. In other words, it is an attempt to overlay and embed more detailed digital images into digitized iconographic image. For example, this is a work co-created with the students of Tokyo Zokai University in 1970. The digitized female density is 18 horizontal and 24 vertical to create a big face of John Lennon. The next one is the portrait of Che Guevara. It is an assembly of color photographs with density variations on 8 levels. 400 small screens gathered to form the face of Guevara, which is full of revolutionary aspirations. There is also the interval frame created by fading in and fading out of digitized images by numerical manipulations and superimpositions. For example, this silver background from which a pink pattern emerges. It was created for the cover design of 1968 magazine Handicraft News. Originally, it's a 4x4 matrix structure. If you look closely, you will see the plus sign, negative and positive of the plus sign in the 4 corners. Let us take out the positive plus and negative plus and inspect them. Vertical 20 into horizontal 20. In other words, a plus sign rises up in a square grid of 400 and both the negative and positive are created in such a way they each have 220 black points and 180 white spaces. The plus sign have the same density. The white cross is neatly shaped with 180 white spaces, but the black cross has 180 black dots forming a cross symbol with 40 black dots scattered around and floating here and there. But both keep the contrast of 220 black to 180 white. I will add 2 spaces in between the positive plus and the negative plus. These 2 spaces are used to create a transition from a black cross to a white cross by throwing out the 180 black dots that make up the cross symbol. From a positive plus to a negative plus, a fade-in effect was created. Any of these images contain dots in the ratio of 180 white and 220 black. Now, I have set up a space where this shape is lined up vertically in 4 rows and the transition in the top row is from positive to negative cross that we just saw. Let us take it as row A. The bottommost row has the reverse system. The transition from negative plus to positive plus is positioned there. This is row B. And the two central columns are filled with overlapping processes in which the cross symbols from the upper and lower rows fade and disappear. I then use 3-step transition points to fade out row A from top to bottom and row B from bottom to top. The pattern in the topmost row A has the size of 3. As it moves down, it fades to 2, 1 and eventually 0. The patterns in row 8 reduce from the bottom row to the top as 3, 2, 1 and 0. The top row of the 2 rows in the center has 2 concentrations. It is a combination of pattern A's concentration 2 and pattern B's concentration 1. The bottom row has A1 and B2 concentration. Arranging all 4 rows together gives an assembly of plus signs. A complex fade-out alloy of positive crosses and negative crosses is created based on numerical operations. The center 2 rows create what can be thought of as a metal-like shining effect. Finally, this was the design that was made. These are examples of applying these numerical operations with photo images as the subject. The images in the corner, top left and bottom left are of the Russian scientist Oparin. They are 2 portraits of the Russian biochemist who attributed the origin of life on Earth to the formation of organisms through scientific evolution. On the top right is a spiral galaxy. On the bottom right is a human fetus. These 4 images are arranged in the 4 corners. Let us look at the bottom row of Dr. Oparin and the fetus. The photo of Dr. Oparin reduces from left to right as 3, 2, 1, 0. The photo of the fetus reduces towards Dr. Oparin's photo as 3, 2, 1, 0. The combination of these 2 images creates a sublime fade effect. A combination of 4 photos that have a complex fade-in, fade-out. The image formed has this kind of an integrated relationship. This image appeared in one of the Xerox newspaper advertisement series called Civilization and Mankind. I would like to take up the rest of the image that was introduced now or its successor, Digiton, another time. Well then, today's part A and part B, it was a little tedious, right? Anyway, I wanted to convey that these were the ideas I would design with in the 60s and the 70s to begin with. I would like to tell you all again that this kind of work was all manual work. Now everybody works with a computer. For example, when arranging pictures in a regular order, call the prototype and click on it one after another, and the picture will arrange in an instant. However, before the 1980s, even in the collage of the eyes you just saw, all the points were drawn with a compass, and the original drawings were drawn in 8 stages, which were then reduced in size using photographs, and photographic paper was pasted by hand to create them through manual work. This was the norm. Even the self-propagating patterns for musical arts were entirely hand-drawn by me. Even the huge collection of shadows on the poster from the World Design Conference was all drawn using a ruling pen, a ruler, and a brush. It was an era when this kind of work was not bothersome. That sort of work was obvious. For this presentation and the patterns that you saw, I got the staff to create the images using a computer, and it was done in an instant. It was a job finished momentarily. I was truly disappointed. From 50 years ago till up to 20 years back, what exactly was all that work I did? I was surprised and was also put into thought. However, while working on this kind of work, there was a unique feeling of pleasure in the flow of time when I was working using my body on cool information aesthetics. It was a bit different from how an image pops up by lightly pressing a few keys on the keyboard of a computer. There was the feeling of anticipation and suspense, a fluttering of the heart. The various images that ran through my brain during the slow progress of the process were also important products. The sensibility of the flow of time while I draw with my own hands is one of the things I cannot forget.